Olá, bom dia.
Good morning, everyone.
Bom dia.
Bom dia, bom dia.
Yeah.
Okay, I
Hi.
think we are all here. We can get the event started, right? Thank you, everyone, for joining us today. A special beginning of a Friday. So this session is dedicated to a few clarifications about the workshops, for the AMADEE announcement of opportunity that was issued very recently. And we are sure that we're going to have many members from the Portuguese scientific community joining us throughout the preparation of the AMADEE mission. I am Rosa Doran from Núcleo, and we are supporting the national steering committee to join this adventure. And together with me, I have the Super Ana Pires. Ana, I hand over to you. Thank you everyone for being here.
Thank you, Rosa. Hello, everyone. I'm Ana Pires, researcher at Inesctec's Center for Robotics and Autonomous Systems, having previously served as flight director at Mission Control for the Monsaraz mission and as a commander for the Camões mission in Terceira Azores. I know firsthand the immense value of these analog environments. Today, we are here to discuss a major milestone. In April of 2027, the Austrian Space Forum will conduct the AMADEE-27 Mars analog mission in the Monsaraz region in Alentejo. This call invites our national scientific community to submit experiment proposals in geosciences, engineering, robotics, planetary surface operations, and life sciences, and many other fields. Rosa, let's dive straight into our presentations and our amazing speakers.
Let's do it. Anna, thank you for the introduction. So today I have the privilege of introducing you to Dr. Gernot Groemer. He's from the Austrian Space Forum, and he is the PI, and will introduce us to the whole vision of the AMADEE-27 that we have the privilege of hosting here in Portugal. And Gernot, you have 10 minutes, and I give the floor to you.
Thank you very much, and greetings from Munich. I'm here together with João Lousada. We're reporting now from the Columbus Control Center of ESA, and so we are having the last weekend of training for our new class of analog astronauts. So in general, to give you a little bit of context here, the Austrian Space Forum has been conducting Mars analog missions for many years. We have been conducting missions since 2003, actually, our first mission. We have been to 16 expeditions so far, ranging from the Northern Sahara to the Negev Desert in Israel. 2 years ago, we were in the Caucasus with the AMADEE-24 mission, in the Oman in 2018, for instance. So we have the experience of being like a ship where research teams can hop on board and we go to remote places that have either a resemblance to Mars or to geological structures that we think that we can find on Mars, like cave systems or so. Now, these missions are pretty big. So typically they involve 200 to 300 people from 25 plus nations. Just a few days ago, we did a quick estimate how many people are already involved in AMADEE-27, and it will be at least 180 people right now, and this number is ever growing. So I think we have a good chance of setting a new record on how many countries will be involved and how many people will be involved, including all the research teams, the flight console operators, the analog astronauts, the ground operations support team. So I should point out that AMADEE-27 is the first segment of a double mission. So the second part will be in 28. We don't know the host country yet. It could be Central Asia. We don't know yet. So basically, it's a stepping stone towards the 28 missions. So we hope that some of the experiments that are being authorized for AMADEE-27 will continue, and we have already negotiations for 28 going on here as well. So the way this works is that the Austrian Space Forum is interacting with a national steering committee where Anna is taking the lead for Portugal now. That is basically enabling everything that happens within the country, whereas the Austrian Space Forum is focused on the operations of the mission itself and all the things that happen outside the host country. So we have been doing a call. I will talk about the science a little bit later on. Going back to the missions themselves, it usually means at least a year or two of preparation. We have a mission support center in Vienna where we have a group of very well-trained flight operators that are basically mimicking the ground segment of a mission, including the time delay, including a reduction in the bandwidth like you would have to expect from Mars. They're monitoring the mission, they're giving advice. So we are switching from mission control to mission support. So this is different to the Apollo missions. And we're having in the field then the crew of 5 or 6 analog astronauts. That number is not fully consolidated yet. We're still analyzing the needs. So the crew is in isolation for typically 2 to 4 weeks. It will be 2 weeks for Portugal. And they are being locally supported by something we call the Ground Operations Support Team or GHOST team. So they are there for things like introducing anomalies, being also a safety net just in case there's a real contingency situation. They are also the control group for some of the human factors experiments. So this is the architecture basically. Now, what we did so far science-wise is we put out a call end of last year for the international experiments. We got a number of many submissions, and we were selecting down to 15 experiments from the fields of geoscience, robotics, and human factors. And traditionally, we also make sure that research entities from the host country are also introduced into the mission. And we have already a couple of Portuguese participants in the science teams already, but we have reserved slots for Portuguese contribution. I will talk about the logistics a little bit later on. So it's the first time we're having a mission where we have more robots than we have humans. So even if we have six humans in the crew, we will have at least double as many robots for the experiments. So when we talk about human Mars missions, we actually talk about human robotic missions. So I will briefly reflect on the experiments that have been selected so far. So this ranges from life support experiments. We have from the Technical University of Munich, for instance, an experiment where we talk about algae growth for CO2 scrubbing and for oxygen production, maybe also food production. We have psychological experiments that also look into reaction patterns for contingent situations from Spain. We are having a major experiment from a DLR, German Aerospace Agency, founded experiment called VAMEX, which stands for Valles Marineris Explorer, where the robots, it's a cohort of robots, are communicating and managing themselves, where we just say, well, this is the area you should explore, and every robot has its own capabilities, if it's flying or walking or rolling. So the robots themselves make out the algorithm how to explore the area with a certain scientific aim, for instance. We also have experiments that involve spacesuit activities. So we're bringing the legendary AUDA spacesuits to the field, complemented by a second class of analog astronaut spacesuit simulators, which are the so-called Delta suits. They are a little bit more advanced, but they're giving not the same amount of physiological workload like the AUDAs do. So for some experiments, we need this. So it's roughly, I would say, half of the experiments are robotics. Then 1/3 is into human factors, and the rest is geoscience. So everything where we get proposals now from the Portuguese side that is focusing on geoscience, of course, is very welcome. I mean, we are very open from the experiment type point of view, but geoscience is certainly something where we would love to have more input. Before we go into more details, I should also point out missions like this do not only involve people from many countries and many technical backgrounds. It's all very interdisciplinary. but they also have a very strong outreach and education component. I know that's something that also, for instance, Rosa is very much invested in Gustavo as well, of course. So there will also be student programs involved that where we will be coordinated by the Mission Support Center. There will be a lot of media attention. That's something I cannot underline enough. We have the experience from previous missions that we are literally reaching out to millions of people. And yes, you heard it right, it's millions of people for documentaries, national news, and so on. So this is expected to be similar for Portugal in 27 as well. A little bit for the timeline, and I'm pretty sure that maybe Anna Pires would be looking into more details on the timeline when it comes to experiment submission. But in preparation for the mission itself, we're going to have in late October a robotics training where some of the experiments will be trained for the crew. They will be followed by 2 major dress rehearsals. So from the 20th to 22nd of November, there will be the dress rehearsal number 1, where the Mission Support Center will be made operational. We're not there yet. We still have to do a lot of building and groundwork in Vienna, in Austria, where we have the Mission Support Center. But we have the technical infrastructure ready. We'll have most of the flight controllers there as well. And the rest is hybrid. So we know not all experiments might be ready for demonstrations yet. It might also mean they're still literally pulling the screws here. And so that all leads after this first dress rehearsal for the 3 days into the dress rehearsal number 2 in February next year, which is actually a congregation of several dress rehearsals that combine in the same week. So there's one that is focused more on the MSc side. There's one that is focused more on the field side. So this will be in the second week of February in 2027 in Vienna Neustadt, which is about an hour south of Vienna. This is culminating in a public day. It will be the largest national space event in Austria next year, which will be on the 13th of February. We're expecting hundreds of visitors, maybe well beyond 1,000, that are getting in touch with the experiments. So we're also highlighting the power of European analog research in one location. It's a big event hall, 2,000 square meters we can fill, and lots of public as well. Also some politicians will show up, I guess. And that means that if you decide to propose and you're successful in submission, you will be included in the experiment complement. There's a process behind this. You will also have an opportunity to highlight your work in your institution during this public day as well. I would like to encourage research institutions also to put up there a booth and maybe also get in touch with future students, with industrial partners. There will be some networking activities. So it's really doing everything we can outside Austria, outside Portugal, that once our teams arrive in Portugal, they are well prepared. The experiments are being well studied, documented, tested, trained. So when we go into the mission, it really runs like a smooth engine. And we have quite some experience on this, but it's a big ship, as you can imagine. We have a small core team at the Austrian Space Home that is full-time devoting to the preparations of AMADEE-27. And our biggest flaw and the biggest privilege we take in this is we try to make it look easy. That's something we are experienced from Flight Project, also in real space missions, of course, that making this look easy sometimes is deceiving. You can imagine just logistics of having dozens of boxes of high-end hardware being transported with all the regulations in place, everything, things like frequency licensing, ethics commission approvals, customs operation, the physical logistics. So that's many things where we try to hide it from you so you don't have to take care of those challenges. That's our job at the Austrian Space Forum. So for instance, the transport between Vienna, where we have the second dress rehearsal in Vienna Neustadt actually, to Portugal will be done in a purely electrical transportation. So we're trying not to burn a single liter of fossil fuel for the hardware transportation. The humans will still have to fly, I guess. And that brings me to the end of the very quick overview about the mission. It's a big mission, I can tell you. And it's not only reaching out to millions of people, but it's also, that's our experience, especially in the host country. It will trigger a lot of interest in the topic of analog research. and it will feed into really highlighting the institutions that are involved. So there's a lot of parallels in the preparing experiments for the AMADEE-27 mission, but also how flight projects are being done. So it is a learning process, and it's an adventure. There's some magic to it, I can tell you for sure, and it's going to be a wonderful mission. Thank you.
Thank you, Gernot. Now let's move to our second speaker, the inspirational engineer João Lousada, also co-leading with me and Rosa the National Steering Committee for AMADEE-27 here in Portugal, who will talk about the challenges of this kind of missions and about his experience as an analog astronaut. He will for sure give us insightful inputs to prepare our scientific or technological experiment. The virtual floor is yours, Lousada. Thank you so much.
All right. Thanks, Anna, and good afternoon, good morning, everyone, depending on the time zone. Indeed, so I put up a couple of slides just to bring up a bit of my experience, and particularly with the training, but then also from being in the field and doing already a couple of missions. First, just a bit of background. So I'm working mostly with this spacecraft here, the International Space Station. For more than 10 years, I've been involved in the operations of ISS. I started off as a systems flight controller. I then progressed to a flight director, and more recently, for the past 3-4 years, I've been on the ESA management role, and I'm currently the ISS operations lead for the European Space Agency. So that means being responsible for the end-to-end operations of ISS and all the European activities we do on board. But talking about Mars and Mars analog missions specifically, so I went through the selection back in 2015 already for analog astronauts. And I remember it being a quite comprehensive selection with around 100 applicants going through medical examination, psychological examination, physical fitness. I remember operating a rover, for example, communication skills. So all of this was assessed, and out of 100, they selected 5, out of which I was fortunate to be one of them, together with colleagues. So on the top, Inigo Muñoz from Spain, Stefan Dobrovolny from Austria, Carmen Kohle from Germany, and Kartik Kumar from the Netherlands, all with also very different backgrounds. So it's been quite a journey since then. But first thing you do when you're selected as an analog astronaut is go to your training. So we do have first the basic training, which has the main purpose of bringing everybody up to a good level of skills before then going into more mission-specific training, and particularly train, for example, the hand dexterity, how you can actually operate with the thick gloves. It's actually 3 layers of gloves, and you can imagine the small, delicate movements that are sometimes needed are not always easy. So it is a bit of a learning curve to also get up to speed on that. A lot of physical training. So our AWUDA suit particularly has about 50 kilos weight, which is equivalent to what a spacesuit would have on Mars. So that is good, but it's still quite a physical effort. And after being outside for 4, 5, 6 hours EVA, you do really feel it. It is a big exertion. So especially working on your core skills, being able to keep your balance also on rugged terrain with that weight on you, it does require some preparation. So it is quite important. And then, of course, we work very closely with the suit. So both inside and outside, we need to know each step of the procedure. We need to know what can go wrong, both from the outside and from the inside, and be able to recognize issues. But it is a lot of the training dedicated to that as well. Of course, things can go wrong, and part of that is being able to handle possible emergencies. The AWUDA spacesuit is a complex equipment. It does have several electronics. It has not happened, but it can happen that we have a fire. And if we have a fire with somebody in the suit, it can be a matter of seconds that may really make the difference. So we do practice and train for these kind of emergencies. We do practice for outdoor skills and let's say expedition skills in medical emergencies as they might be required. But maybe the most important training, it could be the trim work, where I think also as an analog astronaut, it's very clear that you are somehow at the end of a spear with the whole team behind you. So none of these kind of missions are possible just with the analog astronauts, and that's something we're very conscious about. So it's really, I think, a good and important part of the training to really go through those teamwork exercises, through communication exercises, to understand how you fit in a team and how you can make the best out of the team. I think that's really a critical part. And once you complete your basic training and you, let's say, certify as an analog astronaut, you, if you're fortunate enough, get selected for a mission, get assigned a mission, and you go into your mission-specific training. And that's where you really get up to speed and into detail into the flight plan of that mission, into the experiments themselves, the exact procedures, what can go wrong with them. So you really, in a way, become a bit of an expert in each experiment, or you try to be, or you distribute along the team who is an expert on each experiment. My first mission was AMADEE-15 back in 2015 in the Countertall Glacier. This was a glacier at around 3,000 meters elevation, which simulates a bit this environment close to the north and south poles of Mars, this kind of rocky glacier environment, which was quite an interesting mission. Second mission was in the Far Desert, where we looked into locations where water used to flow, so dry riverbeds, as we know, exist on Mars, which could be a good place to look for possible signs of life from the past. And my most recent mission was the AMADEE-20, which was in the Negev Desert, which I have some more slides later on. Now, what I did try to do for you today, which I think is maybe the most interesting part, is collect a bit of lessons learned and thoughts that I had out of my experience. So what works well in an experiment, and what are some of the common, let's say, mistakes that we make when we plan for something on Mars. So I have here a list, and I'll go through them in a bit more detail. If you want to take a screenshot or a photo, this could be a good time as a reminder, let's say. But then going a bit deeper, then first one is designing for the environment. And it's maybe the biggest challenge when you go from the lab environments to the field, is really taking into account all the factors and trying to adapt an experiment or a procedure to work on the field. And here, maybe the first thing is the sand and the dust, which can get anywhere and does get anywhere. So definitely make sure that it's designed accordingly, that it can be withstanding that environment. Consider rain as well, which is not something that you would think about on Mars too much, but we're still on Earth. And if your experiment needs to be exposed for long periods of time and it cannot withstand rain, then also take into account, for example, in the planning, that we are sure it's not left outside. So all of this also needs to be considered. Sun exposure is also a relevant one if it's exposed outside for a long period of time. Temperature fluctuations, so between night and day, again, for experiments that are outside mostly. The rugged terrain is also relevant in the sense that we don't have a working table per se, so no flat surfaces. So think of that as well, that your equipment is able to withstand that environment. Then different planets, different time. So be aware of the time delay that we have in these missions. So for the OVF, we do a 10-minute time delay. We keep it steady, so it's not fluctuating as it does between Mars and Earth, but it is a good average to consider. So don't expect to have real-time feedback. So if your experiment needs to be, you need to know exactly what happened right away, this will not be possible. You will receive it with 10-minute delay. Also, don't expect to be connecting to your experiment directly, so you're not able to command it real time and to have telemetry. So this, again, like on Earth and Mars, real time is not possible. Think of the interactions, because if there is a bit of a need for feedback or questions, yes, each way is 10 minutes, but you also need to then come up with an answer afterwards and send it back. So at least 20 minutes plus the time that needs to be actual answer the question or the feedback. Then plan for crew autonomy. So as much as crew can do on their own, the more efficient it is. If we need to keep asking questions and can we go for next step, do we have to wait? This will make things less efficient, of course. Then number 3, flexibility. So I think I cannot overstate this. Things will go wrong. That is a bit the point of these missions, is to see what goes wrong. But what can go wrong are things like sandstorms. It's things like delays on the donning. The donning is the putting on the suit, the OODA suit. This takes on average, or at least in the beginning of the mission, about 3 hours. It's more than 100 different steps, and you want to make sure that you do them properly. As the mission progresses, we get more efficient and it gets quicker, but there's always a bit of fluctuation. Also, if something goes wrong during the donning, there's maybe a need to redo some steps. So the timeline might not be exactly as it is on the schedule. There can be loss of communication. There can be the need to navigate. So all of these things can affect what was the planned timeline. So the message here is, the less constrained your experiment is, the more likely it is to succeed. So if we can adapt to it, if we can do it 5 minutes later, 10 minutes later, if that's not an issue, then it's good. If it needs to be a very precise timing between runs, for example, that could be an issue or could be hard to implement. So take that into account. Then crew time as resource. I think you know, but I think also doesn't hurt to mention that it is one of the scarce resources we have during these missions is really how much we can do. So from the crew side and from everybody in the OVF, we want to do as much as we can. We want to do everything, but there is a limit to how much we can actually do. And so a lot of the times it's limited to the amount of crew time. So the more we can optimize the crew time, the sequence of activities, the avoiding needing to repeat tasks or to, let's say, assemble, disassemble an experiment if it's not strictly required, take that into account as well, I would say. Then suit constraints are maybe the ones that are harder to grasp. So just, I mentioned the gloves a bit, but we're talking about 3 layers of gloves. And I think the best analog or the best comparison I can give is try to do your experiment with oven mitts. So the ones we use to open the oven and to get the warm food out. If your experiment can be done with those on, then it's a good experiment. If you see a difficulty there, then maybe something to think about. Think of big buttons, think of interfaces that are easy to operate, switches that are large enough and not that you need very precise movements. So all of that is relevant. Think of the weight, the 50 kilos on the back. And if your experiment is 20 kilos, maybe it's not so much, but 50 plus 20 starts to add up. Visibility is not the best. So in terms of lateral visibility, so it's a narrow field of view. Movement is a lot more constrained. So for example, bending down is okay. Standing up again is not so okay. So whenever things need to be done on the ground, they take quite some effort. So this also limits physical capability, but then how much we can do in the EVA, maybe after 1, 2, 3 of those get down and stand up, then we need to take a rest because 50 kilos on your back, again, it takes its impact. Then I'm blocking my own text here. What was the working area? Yeah, so I mentioned this. So ground level, as it's on this photo, was not ideal. That's something I remember this mission and this experiment particularly, that having to bend down frequently was not appreciated, let's say, not easy. Communications might not be there all the time. So if your experiment needs a constant, for example, voice recording, that might have some gaps, or we might not always have communication available between the habitat and EVA. So think of that as well. And think of the traverses as well. Traverses, the, let's say, location or the traveling from one location to the other with your experiment. Consider that as well. Then this links directly to the transportability. So consider the weight and the volume. I think this is changing automatically. Let's see. But yeah, think of how to transport your equipment, especially if it's on the EVA. Think of the weight, the volume. Does it need to be packed, repacked? Do we need to assemble it on the field with EVA? So all of that needs to be considered. Then getting close to the end, I have my slides changing automatically. But so number 7, training and procedures. So you are the experts, so try to transfer your knowledge in a clear way. And that's done through procedures, but also through training. So you have the OVF team with a lot of experience that will support you, especially in writing procedures. There's a lot of background experience there. They will help you get there. But also best way, or maybe some advice, is to get somebody from a different department or somebody, a colleague or a friend, and just have them run your procedures. You go through your procedures. That's maybe a good way to see if they're clear or not. Just have somebody who has no clue what the experiment is about or very little knowledge, and see if with the procedure it's clear enough for them or not. I think that's Then final one I have is robust and replaceable. So make sure your equipment is robust because it is an operational environment. Things can break, they did break, they will break. That's, again, a bit the point. Question is what will break. But as much as you can do in terms of design to make them robust, as much as you can think about what can fail and have spare parts will be good, as much as you can make your experiments repairable as possible, replaceable, and using as much as possible standard equipment, standard parts, standard tools. So if you need a very special tool that we might not have on the field, then it limits us how much we can actually do for the experiment. Again, if you have a cable that's standard, the Ethernet cable, that's something we can easily find on the field usually. If you have a very special tailored cable, that again will not be easy to find or to replace. We did it in the past, but takes then some soldering and a bit more creativity, let's say, to get that done. And then here I have some examples of experiments we did in the past. I don't know how we're doing in time, but just to say, so drone, 1 minute is just to show some nice experiments photos. So we had drones that actually tested the software that was later done on the Ingenuity rover, Ingenuity drone on Mars. We tested, and Rodrigo will talk more about it, robotic operations, which was also done from ISS. Different experiment, but similar concept where if you are on Mars or on the orbit of Mars, you can operate rovers in real time or close to real time, opposed to what we did today with a time delay, which means you can explore a lot further, you can more quickly replan and navigate. So you can actually get a lot more out of the rovers just by being close to them. Even from Mars orbit, you can already do a lot more than what we can do from Earth today. We tested some radiation protection vests. This was then later flown to the ISS as well. This was a company from Israel in collaboration with Lockheed Martin. And here it's protecting the vital organs out of radiation. We tested some equipment also to follow along during the mission, the optic nerve and how that evolves, because I'm sure some of you know as well that during spaceflight, especially zero-G, we do see a deformation of the optic nerve is one of the effects of microgravity on the human body. So it is important to have a good tool to follow that along during the mission. And you see here Matthias Maurer also using that on board the ISS. And I think final slide is one that I think still inspires me a bit. It's a photo taken from the surface of Mars, looking back at Earth. So there's a small dot on the top left, and that's what the first human explorers might see from the surface of Mars when they look back at Earth. And for me, that's still a special moment in the future, and to think that we are one way or another contributing to that future, and that's still special for me. So I quite like this image still. And I would wrap up here. So you have here my contacts. Feel free to contact me for any questions, but also, I mean, here, I think we'll still have a bit of questions, but I'll leave here my contacts in case anybody would like to contact me. I am available, happy to chat. And with that, Anna, Rosa, back to you.
Thank you very much, João. That was inspiring. I almost feel like I want to be young again and to become an analog astronaut. But yeah, don't think it's going to be in this lifetime. So we move to our final speaker. We welcome Professor Rodrigo Ventura, and he will focus on the part of robotics systems and technological expectations for the experiment proposals. So Professor Rodrigo, the floor is yours. As Anna said, the virtual floor is yours. And we will continue towards the rest of the presentation afterwards.
Okay, thank you, Rosa. Can I share? I also have a few slides, but I think I need to ask your permission to share.
Go ahead.
Let me just...
So Rodrigo, for me, was underneath in the more, and then there was the share button.
Okay. No, the problem is that I was not allowed, but now I am. Thank you. So can you see the slides?
Yes, perfectly.
Okay, so first of all, good morning. Thank you so much for this invitation to be in this session. I'll try to be brief. I'll talk mostly about our participation in AMADEE-20, although we also participate in the AMADEE-24. So I am associate professor at IST, also research at ISR Lisbon, and also adjunct faculty at ISU. And my backgrounds are AI and robotics, and I've been focusing in past 10 years on space robotics and the application of AI to space. So ISR, we have a research group called MEROP, where we put together two research institutions. So one is ISR, more focused on robotics and information processing, and ITI, more focused on human-computer interactions. So we bring these two backgrounds of on building robotic systems, and also in doing that, taking into account the human in the loop, and with all of these expertise on how to design interfaces that have humans in the loop. Now, the core team of our experiments, it's me, Professor José Luís Silva from ITI, which brings expertise on HCI, and Jessica and Ruth. At that time, they were PhD students. Jessica already concluded the PhD, and she is now faculty at ISEL, and Ruth Luz is currently at ESA. She participated in the same experiments on the ISCS, and she's finishing the PhD. And if you want to know more about the research group, there is here a link. Now, as I mentioned, so we are not originally a space group, and we started working on robotics for search and rescue. So in emergency situations where it's dangerous to send firefighters, the idea is to use robots to look for victims. That was the initial motivation, and for that we needed to design interfaces that would allow real-time teleoperation of robots in field conditions, and that brought us to the design of haptic interfaces for the operators to have a better perception of the environment. And so we found out in previous experiments that the orientation of the robot, so whether it is horizontal or is it climbing something, and the traction, which means the robot got stuck or start sliding, are two conditions that just for the camera are hard to understand. And therefore, we designed these haptic interfaces, which are basic interfaces that you feel with your hands situation of the robot. So we designed two of them. One is an haptic, the attitude device that rotates your hand according to the attitude of the robot, so that you can feel in your hand the orientation of the robot. So you have so the device will rotate your hand, and then using a laser rangefinder, you are able to detect when the robot loses traction, when it gets stuck, and then it vibrates the glove, which is this glove interface. Okay. And then as we started looking into space applications, we had an idea of migrating this to space. And we saw I think it was in 2018, we saw a call by Austrian Space Forum about this analog mission, the AMADEE-20, and we sent an email to Gernot. I don't know if you remember, and Gernot answered, "Yeah, so let's talk about it." So we had a call, and then it was amazing. We learned a lot about AMADEE, and we got enthusiastic, and then we built a proposal. Our initial question is, does it make sense to participate in AMADEE? After that call, we got convinced, yes, let's go for it. So this is the sketches of the concept, which is we have a robot outside of the base. We have inside the base an analog astronaut teleoperating the robot with our devices, and then the idea was to test this interface on the field on an AMADEE-20 mission. Okay, and so that brought us to the construction of a suitcase that contains a laptop, the two devices, the haptic and the traction glove and the joystick. And the idea, as you can see in the picture on the right from one of the dress rehearsals on an analog astronaut, trying out a robot that is nearby using the interface. And so here the challenge is we are not going there, right? We are going to be in Vienna in the mission control center, and we will need to ship this suitcase that needs to be sufficiently robust and autonomous for an analog astronaut to be able to open it and make it operating with the robot. Okay, so this was also a learning experience for us on how to design this equipment that we ship it, and we are not going to be there to replace anything. Okay, so this is also an interesting challenge. Okay. And then we didn't have a robot there, and so we asked for, can we collaborate with the other team that has a robot? And then that sparked the collaboration with the Exoscout team from TU Graz. Coincidentally, I knew already the PI from previous interactions in the search and rescue area, because we both participated in RoboCup competitions. And then we get in touch with them. We had our PhD students there to integrate our system with their robot, and this is also an interesting opportunity to collaborate in the mission. And now the mission, we got lots of data. One of the data is recordings of the operation. Let me just mute it on my side. And so this is a video that we record from one of the analog astronauts setting up the system. So putting the gloves. So they opened the suitcase. They had to put all of the devices on the right place. So this is footage from the inside of the habitat in the Israel desert Negev. And then so we collected all of the data of usage of the robots. We also ask them to do something called talk aloud, which is to verbalize everything that goes through their minds, and that was recorded also in the video stream, so that we can understand the thought process on using the interface. Okay, so the main the data that we get from these experiments is mostly human factors, which is how do the analog astronauts use this interface. And analog astronauts, they are a particular user group that we have been focusing a lot, which is so they are not a public, they are not any person, okay, but they are not also experts in robots. So they are very well trained persons in procedures, but they are not experts in robotics. So that forces us to take that into consideration when we design this interface. So we need to write clear procedures in a standard way that is also a learning experience for us. And yes, so here is some footage of using. So you can see on the left the device rotating. So that rotates according to the orientation of the robot. One interesting observation that we got, and we are not expecting, so this was also interesting, which is so we got a report that through the haptic interface, they were able to feel the kind of ground. So if it was like a sand or with small rocks or just plain, and the device would allow them to feel the ground on the robot. That was unexpected, and it was interesting. And of course, it improves the situational awareness, meaning that they are able better to understand the context of the robot. So to finish, still, what did we learn from that? So what are the outcomes? So of course, the opportunity to deploy our system in a realistic analog mission outside of our lab. And this is in robotics, this is super important, because one thing is to do our robotic experiments on the lab where we control everything. Completely different thing is to do the field outside of the lab, and this is an opportunity for doing that. I mean, one step further, because we are not there on the field, so everything has to be self-contained and ready to be used. The collected experimental data that we got, which I mean, still today we are still giving some use to it. We are doing other analysis outside of the context of the experiment, and so this is gold, all of the data that we got. International collaboration, we can use a team, and of course any international collaboration is also a learning experience. Networking with other teams, because we besides the rehearsals, there was also a workshop, a scientific workshop at beginning and after the mission, and that is also a great opportunity to network with other teams, and learning a lot about realistic space procedures. So as I mentioned, we are not space people, and so it was for us a learning experience how to design this, all of the paperwork, the procedures, and how do we need to adjust our experiment to the requirements of a mission. And of course, it also mentioned here the media exposure also allowed us to attract lots of students for thesis, because I mean, space and analog missions is a very attractive an area. We are able to get motivated students from that, and also we got lots of lessons that also fed directly into the AMADEE-24 proposal that we did after it, and then we also participated in that analog mission. And this is it. So thank you.
Rodrigo, thank you so much for your presentation and for sharing your valuable experience, because you already have experience in submitting proposals under the scope of these types of missions, and it was important to hear from you and have these insights from a past AMADEE principal investigator. Now, Rosa, let's quickly walk through the practicalities of the national call. This call is open to PIs, researchers, and students from universities, research centers, and industry, as long as the PI is affiliated with a Portuguese entity. Rosa, are there any more topics that you would like to point out very quickly?
Well, just let's finish what's important for the calls. The deadline, full proposals must be submitted electronically to, I will put the email here. It's AMADEE-27 at ovf.org. I will put that as soon as I finish talking. no later than September 6, 2026, 23:59 CET or CEST. The format submissions require a PDF containing a cover page, the team expertise, a signed A27 compliance form, and a concise scientific technical description. And because in terms of priority, because crew time inside the habitat is heavily restricted, as João and Gernot presented, experiments focusing on extravehicular activities, AVA, or require little to no internal crew time will be given higher priority. So I don't know if... yes, go ahead. Yeah.
On the website for AMADEE-27.org, there's a list of the existing experiments already. Maybe you find also docking points to those. It's already there. Yeah. Thank you.
I don't know if any of the presenters would like to say something else. Gernot, you mentioned several times in your presentation that later on you would like to cover a few more details. So now it's the time to do that. If you have anything else to add.
No, again, if there are synergies with existing experiments, that of course is preferable. Again, a focus on geoscience is also welcome, but it's not restricted. It's open to all types of sciences. I think what is most important is we are hoping for team applications and not so much individuals, because there's a risk if there is, let's say, a PhD student who wants to do something that does not have a significant support from the institution, that this is a risk where life events can throw back. And so that's also one of the things we're looking into is also, is the proposing team really capable of executing the experiment within the given border conditions?
Perfect. Gernot, we are really on time. We are almost simulating the Mars missions, you know. So we are really on time. We have 10 minutes. Rosa, can we open the floor for questions for the ones that are here online? Please use the chat or raise your virtual hand.
Go ahead. If there is any question from the audience.
Marco, please.
Marco.
Yes, hello. I'm Marco. I'm from the municipality of Oeiras. We have worked with Nucleo before, and we are very interested in this particular mission that you are presenting. We are going to be looking towards our regular partners to try and find a project that may fit the objectives of the AMADEE-27 experimental mission that you're here talking about. I had to take a call, so I didn't really get all the information regarding the experiences that might go to Vienna. I remember Gernot speaking about this. Can I get a little bit of a redo of that part so I can, yeah, thank you.
Details are also laid out in the announcement of opportunity, but there are 2 dress rehearsals preceding in November and in February. Then during the mission itself, where we have the full complement of the Mission Support Center set up, there's also a section, the MSc, that is for remote science support, including the experiments. So we are asking that every experiment has one liaison in the Mission Support Center as well, because even if we have a mission plan that says on that particular day, on those hours, the experiment is executed, there still has to be some flexibility that is due to the, whatever happens short term in the field. And we also saw that this synergy effect of having the researchers literally sitting around one large table and discussing the data has an incredible added value, not just for networking, but mostly scientifically as well. So we are asking the PIs, especially ones that do physical experiments, to have one person as a liaison seconded to Vienna for the duration of the mission.
Oh, okay. Thank you. That makes it a little bit clearer. Also, you said that even though the call had finished, yes, for new experiments, there were some spaces for or some slots for Portuguese experiments. How many slots are still available? Can you provide that information at this time?
We do not say a number because it depends on the extent of resources that are being used. So we know we have X power, bandwidth, analog astronaut time, and depending on what the package size is for each experiment, we can onboard several experiments or maybe one. From experience from previous missions, it's usually around, I would say, like 2 experiments or so, 1 or 3. So we're talking about a single-digit number for sure, because we have all those restrictions that João just mentioned before. Yeah.
All right.
So sometimes, if an experiment is rejected but still interesting, sometimes we can glue it to an existing similar experiment, and it's an extension package. And then maybe if you look into data sharing, maybe that's a less invasive method of being involved. Yeah. And remember that this is the first part of a double mission, actually. So when you plan for it, we're looking for like funding sources on the midterm or long-term perspective. Maybe you also want to consider already planning for a 28 mission as well. That's towards the end of 28, by the way.
Okay.
So
thank you for
rather
the
prefer. Okay. So experiments that take small baby steps initially are more that are less ambitious. That's sometimes a more realistic approach, and not do all complexity for the first time on the first attempt. Yeah. Use 27 as a stepping stone.
Okay. Thank you for that clarification. I'm sure we'll try to find something that might fit what you are looking for. And thank you all for your presentation so far. And I wish you good luck in your continued endeavors.
Thank you so much, Marco.
Can I add something? Marco, just to tell you that Portugal is very privileged to have AMADEE coming, because the infrastructure that is being created for AMADEE will stay here. That means that, and also the partnership that will continue exploiting the site in Monsaraz. It has as partner OVF, that you see here through Gernot, Inestec through Anna, and the educational part from Núcleo, and of course the site. So at any point in time, we will be able in the future to organize national missions with the support of this wonder team. Of course, if Oeiras wants to take a first seat in this opportunity, now it's the time to get on board. I'm just taking this opportunity to let you know there are conversations that started, but this is the perfect time to reserve your seat in the front row and have the possibility to run all Oeiras mission or even international mission coordinated by Oeiras with privileged access. And this goes to anyone willing to take part in the construction of this beautiful thing, okay? Anna, if I may, sorry, you want to say something, Marco?
Yes, I was just going to say that given that you already know how Oeiras works, we are already thinking on how we can take advantage of this opportunity to do something together with you. So expect to hear from us soon.
Looking forward to it. I mean, it takes visionaries to see how big this is going to be. But the winds that are coming from the reactions of people and companies and universities for the news that the habitat that is going to be created for AMADEE is here to stay, it's already bringing big voices. I want to take the opportunity to share with all of you something that is important. Anna already shared this, and you can see here the habitat that was used by the world biggest analog crew, the Portuguese crew during the world biggest analog, that was also supported by OVF. OVF was one of the teams behind behind the screen. This is exactly how it's going to, well, the permanent habitat will be better than this one. This was just something temporary, but this is what you're looking for. And this is the web page of AMADEE 2027 Mars simulation. And here you can find information about the possibility to present your experiment and all the instructions to do so. So here you have all that you need to know, okay? So Anna already put this on the chat. If you don't have access of the chat because you are watching it at a later stage, it's ovf.org and AMADEE-27. Not difficult to find it. So good luck to all experiments. Good luck to everyone willing to take part. And good luck to all the ones that want to be in the first row.
Thank you so much. I think that we still have time for one more question. Does anyone? Okay, I think everything was clear. Please do not forget that all the experiments must be self-funded. Don't forget also the logistical considerations and timeline constraints. Professor Rodrigo talked about that. Please view again the video. This recording session will be available for you to see and share. So please anticipate regarding the hardware delivery, customs clearance, etc. And please take these final points into consideration. So thank you to our speakers and everyone who participated today. We look forward to seeing your innovative proposal for AMADEE-27. Please note that this meeting is being recorded and will be made available online on our platforms for anyone who wishes to revisit the details later. So if you are watching, all our contacts are in the announcement opportunity document. Do not hesitate to contact us. And also, if you are interested in becoming a partner or sponsor of AMADEE and the future research station that will be built and will be born in Portugal, in Alentejo, in Monsaraz, please also contact us directly. Thank you once again. Have a great rest of your day. Thank you, Rosa, for sharing with me the moderation. Thank you to all our speakers. See you very soon and welcome AMADEE-27 to Portugal.
Thank you very much.
Thank you. Thank you.
Thank you. Bye.
Thank you.
Thank you. Bye.